So welcome everyone. Welcome to the online lecture for the NPTEL course on water and wastewater treatment. So this is the last week for week 12 lectures, and as you all know, the course instructor for this course was Professor Bhanu Prakash, and he is from IIT Roorkee, and I am one of the teaching assistant for this course. My name is Akash Shah, and I am a PMRF scholar at the Department of Civil Engineering at IIT Madras. So here I am pursuing my PhD in environmental engineering. So we will quickly go through the contents of week 12 lecture. So in this week 12, we learned first about the residual management. So basically, what are the different types of residues that we get from the wastewater treatment plant? What are its sources, the properties, and what kind of management system do we use? And then we learned about the solids computation. And after that, some of the management techniques like sludge thickening, where we learned about gravity thickening, belt thickening, then dissolved air flotation, and their respective design criteria. Then we moved on to the stabilization of sludge. So what are the different methods like anaerobic digestion, aerobic digestion, autothermal aerobic digestion, composting, and lime treatment. And at last, we learned about the dewatering, disposal, and drying of the sludge. So this was the brief overview of the sludge management system that we have for any wastewater treatment plant. So today's questions are also based on that. So basically I have some multiple choice questions and some also subjective type numerical questions. So we will go through them one by one. And if you have any doubts, you can stop and ask me anytime. Okay, so this is the first question. Says that match the following residual characteristics with the type of residual. So we have three types of residual. One is the primary sludge, secondary sludge, and the mechanically dewatered sludge. And as far as the characteristics are concerned, some are like wet mud to chunky solids, where the solids concentration is 15 to 40%. One is of microbial mass type, where the solids concentration of is around 0.5 to 1.5%, and the last one is organic plus inorganic fines, where the solid concentration is 4 to 6%. So we have to match them accordingly with their with their particular type of residue. So can you please answer like which of the option can be correct? So you are saying it as A. So for secondary sludge, it should be a microbial kind of mass, because all the microbes will be settled and the solid concentration will be very less, around 1.5 maximum. And the primary search will have both my organic and the inorganic fines. So option C is correct, 2 with C. And for third, mechanically dewatered sludge, like the since after dewatering, the solid concentration will drastically increase. So it can reach up to around 40% also, and it will be kind of a muddy and chunky solid. Okay, so option A overall is correct. So 1 with B, 2 with C, and 3 with A. So this was about the first question. Let's move on to the next question. Treatment of which of the following will require stabilization? So here we are talking about only stabilization. So what kind of solids will require treatment? Whether it's a settled inorganic sludge from grit chamber, whether it's for hardness of water, or heavy metals, or for secondary settling tank sludge. So which of the following will require stabilization? Option D, yes, definitely it's correct, because the secondary settling tank sludge will have a lot of biomass, and to remove the pathogens, it is always required to stabilize it. So stabilization is basically required for these kind of sludge. So option D is definitely the right answer for this. We'll move to the next one. Which of the following statements are not correct for a digester which is producing methane? So here we are talking about the digester which is producing methane as the byproduct. or the final product. So the digester is provided for stabilization of sludge. So the four options are: aerobic digestion is taking place in the digester, carbon dioxide is also being produced along with methane, the sludge in the digester contains inorganics in high concentration, which is favorable condition for the digestion. Anaerobic digestion is taking place in the digestion. So which of the following statements are not correct? So first we have to find out what kind of digestion is taking place. A and C. So yes, because since methane is being produced, so it is an anaerobic type of digestion. So definitely option A is not right. And then carbon dioxide is definitely a byproduct with methane. And the sludge contains inorganics, which is not a favorable condition. So option C is also not correct. And option D, anaerobic digestion is taking place. So option A and C are the correct options for this question. Okay. Okay, so we'll move to the next question now. So we have a flow chart. So we have to find out the missing variables. So we have a composite waste which contains carbohydrate and proteins, and it is going through a number of steps. And at last we are getting methane and CO2. So we have to identify what are A, B, C, and D. Option D. Okay, so the first process that is being happening, so where the carbohydrates and proteins are changed into monosaccharides and amino acids. So basically a long chain polymers are being degraded into short chain. So basically hydrolysis is happening. So option A is hydrolysis. Then the acidogens will be acting and forming various kind of uh, acids or VFAs in the system, and later it will be changed to alcohols. So that process B is known as acidogenesis, and then with the help of acetogenesis we will get the acetic acid. So C is nothing but acetic acid, and at last where these acetic acid will be changed into methane and carbon dioxide. So with the help of methanogenesis it happens. So D part is methanogenesis. So the correct option will definitely be D. So first hydrolysis, then acidogenesis, acetic acid, and methanogenesis. So all these questions are pretty simple. We will just go through them quickly, not a big concern. Okay, the next question. Consider the following statements related to anaerobic digestion of sludge. So we are talking about anaerobic digestion. Alkalinity of sludge plays a favorable role in the anaerobic digestion of sludge. For methanogenesis, the optimum pH range required is 6.8 to 7.2. So are the above two statements related to each other? And if yes, so we have to find out the correct options. So options are yes, no, and then two reasons are given. So reason is given that alkalinity is a form of bicarbonate, so which combines with the H plus ions to form the acetic acid, and therefore leading to considerable reduction or increase in the pH. So you have to find out the particular reason. So first we have to answer whether the above two statements are related to each other or not. And if it's related, what is the reason? So yes, definitely the two statements are related, because with the help of this alkalinity, we are able to maintain the pH in the system. So basically, in for the methanogenesis process, the pH required will be around 6.8 to 7.2. So this alkalinity will definitely help us in maintaining the system. But how does it maintain? can you tell me which one of is the reason? Option C or D? Which one can be the reason for this? One is talking about reduction in pH, one is talking about not pH, no pH reduction. So basically this alkalinity, yes. So option D is correct because this alkalinity is giving some buffering capacity to my sludge. So whenever buffering capacity is there, it will take up those H plus ions, and even if some acids are being produced, there will be no significant drop in the pH. So whatever the initial pH or the optimum pH we are setting for our sludge, anaerobic sludge digestion, it will be maintained because all these acids will be consumed. Okay, and it will give some buffering capacity because definitely during the acidogenesis processes, many acids or volatile fatty acids as we call them, these acetic acid and all, will be produced. So having the alkalinity in the system can be helpful. But if there is no alkalinity uh, is there. So not much alkalinity is there. So definitely the pH will drastically remove. And we know these methanogens are very sensitive. So even if there is a slight change in the pH, if it goes to the acidic range and all, so they will stop working, and our process will definitely will become inefficient. So option A, yes, and option D, that they will help in preventing the reduction of the pH. Okay. So now we have a numerical here. So though it looks like a pretty big numerical, but it isn't actually. So it says that a wastewater treatment plant consists of primary treatment units followed by an activated sludge secondary system. The primary and secondary sludges are mixed, thickened in a gravity thickener, and are sent to further treatment. A schematic of the system is shown. So basically a schematic is just given. So we don't have to worry about it, what is there in the schematic. We can directly see the characteristics that has been given. So the characteristic given is the influent suspended solids is around 200 milligram per liter. So out of which 58% is being removed. Then the BOD influent is 225, out of which 32% is removed. The effluent suspended solids is 20 milligram per liter. F by M ratio is also given. The flow characteristics is given, like what is the flow, 19,000 meter cube per day, and the biomass conversion factor is also given. So we have to find out the total mass of the solids, including the primary and the secondary, that are being generated in kg per day. Okay, so just focus on the characteristics, and with the help of the schematics we can find out the answer. So try to note down the question. I will solve this, or if you are able to solve it, please tell me the correct answer if you are solving it. I wait for a minute. Okay, we'll solve it. So first we will, this is question number 6, I think. Question number 6. So first we have to see how much primary sludge is being formed. So first will be my mass of primary solids. So what it will be? It will be the suspended solids removal efficiency into the influent suspended solids into my flow rate. So this will be, so in total flow rate, if it multiplied with the influent suspended solids, we will get the total amount of suspended solids, and out of that how much is getting removed. So it will be 0.58 into 200 into 19,000. So it will come as 2204 kg per day. Okay. So now we will move on to the next step, that is BOD removal. So how much BOD is being removed in the primary clarifier? So BOD removed in primary clarifier, it is actually given as 32% of influent BOD. So generally 30 to 35% of BOD is being removed in any primary clarifier. So it is given as 32%. So that will be 0.32 into 225. So that is 72 milligram per liter. So now total that was coming in the primary clarifier. So if we see, so suppose this is my primary clarifier PC. So in this 225 milligram per liter is removed, is incoming. Out of that 72%, 72 milligram per liter is removed, but still some part is going. So how much is going? So we can write it as 225 minus 72, so equal 153 milligram per liter. So this one is going to my secondary system, okay. So this much is going in my centrifugal. Now we can find out how much BOD is removed in my secondary system. So how can we find out? So BOD removed in secondary treatment. So my incoming was 153 minus the effluent BOD. So the effluent BOD is given as 20. So 153 minus 20, it is 133 milligram per liter, or we can write it as 0.133 kg per meter cube. Okay. So again, if we draw the diagram, this is my primary clarifier. In this 225 was coming, 72 went, 72 was removed. So 153 went ahead. So in my secondary treatment, 153 came, out of which effluent was 20, and the one thing was removed was 133. Okay. So now we have to find out the mass of the secondary solids. Mass of primary solid we already calculated. So mass of secondary solids. So this is nothing but the biomass conversion factor that is given. So biomass conversion factor into the BOD removed into the Q. Same as our primary, similar calculation is there. Biomass removed and Q. So it is given as 0.35 into 0.133 into 19,000. So it is around 884 kg per day. 884 kg per day. So ultimately, my total solids will become, so my primary solids plus secondary solids. So that is 2204 plus 884. So it is 3088 kg per day. Is it okay? Anything, anywhere you have missed anything? Okay, just briefly I will tell once again. So first we have to find out the mass of my primary solids. So it is nothing but the removal efficiency of my suspended solids into the effluent suspended solids into the flow rate. So I got the mass of my primary solids. Then I will check how much BOD is being removed by the primary clarifier, then how much is entering into my secondary system, and then how much BOD is removed in my secondary system. So from that I can get an idea about my BOD. So now that BOD, how much is being converted into my secondary solid. So we'll use the biomass conversion factor, the BOD removed, and then the flow rate. So I got it as 884 kg per day. So my total will be PS plus SS. So that is 3088 kg per day. So mostly all the questions uh, in this weeks are somehow related with this concept. So we have to basically find either the primary solids, secondary solids, what is the density, what is the specific gravity, all depends depending on all these factors only we have to calculate the solids. So every calculation is more or less related to solids. Okay. So the correct answer is 3088 kg per day. Okay, so we'll move to the next one. Again, a numerical. So it says that the thickened sludge from the sludge thickener is to be digested anaerobically by a standard rate digester. So here we are talking about digestion. Volume of thickened sludge per day is 77.2 meter cube per day entering in the digester. So this is the volume of sludge entering per day in the digester. Total mass of solids in the thickened sludge is equal to 3088, which we is found out in the last question, 3088. Now this sludge has 70% organic and 30% inorganic particles in nature. And after that, approximately 60% of the organic fraction is converted into liquids and gaseous end products after 30 days. And thus digested sludge has a solid content of 5%, which has to be stored up to 90 days. So we have to find out what is my accumulation of this digested sludge rate of accumulation of this digested sludge per day. So basically you have to find volume per time, meter cube per day in the digester. So some extra information is also given. So don't look into all those things because period of 90 days or whatever, some extra informations are also given. So we have to just focus on the main inputs that is being given. So what is the volume of sludge that is entering? What is my mass of the sludge? How much part is inorganic and organic? So we'll get to know the idea of the mass of the sludge, and then how much is being converted. So with the help of those information, we can find out the total mass of the sludge that is being produced, and then the volume, and later the volume per day. So please note down this problem, the various input parameters, and then we will solve it. I'll wait for some time. Okay, shall I solve it? Okay, I'm changing the screen. So in this question, the sludge loading rate is given as 77.2 meter cube per day, and the total mass of solids is given as 3088 kg per day. Okay, so now this total mass of solids is given. So now this mass has 70% of organic and 30% of inorganic. So my organic solids will be zero point 0.7 into 3088 kg per day, that is 2161.6 kg per day, and my inorganic solids is 0.3 into 3088. So this is 926.4 kg per day. So this would remain as it is. So since it is inorganic in the digester, this would remain as it is, whereas my organic solids will be further digested anaerobically and some part of it will be removed as methane, carbon dioxide and other gases, and the rest of the solid sludge will be remaining again. So we have to find out what is the solids, organic solids left after digestion. Okay, so I will write since 60% is digested, organic solids left will be equal to zero point 0.4 into 2161.6, 864.64 kg per day. So this much is still remaining. So what will be my total mass? Total mass of solids in digester. So that will equal to my first my inorganic part, 926.4 plus the organic part that is remaining even after digestion. So this is 864.64. So this will come out as 1791 kg per day. Okay, so this will come out as 1791 kg per day. Now at last we have the final answer that we need is the sludge accumulation rate per day, or sludge accumulation rate per day means the rate itself. So my sludge accumulation rate would be 1791.04 divided by the density into 0.05. So this is 0.05 is the 5%. Okay, is it 5 was given 5%? Yes. So 5% solid content. So that's why 0.05 is coming. So it will come out as 35.82 meter cube per day. So this is my final answer. Is it okay? Anything that you have any doubt? Any concerns about this question? Hello, are you able to follow this? I can go through it once again if you want. I'm audible. Okay, you are saying that the sludge has water and solids both. But see, in the question, it has clearly been given the total mass of solids. The second point that is given, the total mass of solids. So we have to uh, now don't worry about the water part because the solid mass is given directly. If there would have been the total mass of sludge is given, then we have to segregate water from it. But in the question, it is clearly mentioned and it's basically a thickened sludge. So now the solids concentration has moreover increased and the total mass of solids is given. So we don't have to worry about the water part here in this question. Okay. Say I will just make you understand briefly. So suppose this is my digester. So in this, yeah. So this is my digester. So the question is saying the total mass of solids. Okay, forget about the water part because here we are it is directly given how much solids is entering. So solids that is entering is 3088 kg per day. Okay, this is entering. Now out of this, it has some organic content and some inorganic content. So organic content is given as 70%, inorganic content is given as 30%. Okay. So now out of 3088, if you see the 70%, 2161. So 2161 is my organic part and 926 is my inorganic part. This is what is entering into the system. Now this inorganic part will not degrade because in our anaerobic digestion only the organics will degrade. So this will be there as it is. Nothing will happen to this. Whereas in the question it is given that 60% of my organics. So this organics 60% is degraded. 60% is degraded. So the left is 40%. So now zero point 0.4 of this 2161. So this is how much? 0.4 of this 2161 is 864. So this is 864. So after 30 days of digestion, so if I do after 30 days of digestion, my inorganic part will be as it is. Inorganic part will be 926. Whatever was there upfront, it will be 926. Whereas my organic part, so earlier in the initial part it was 2161, but out of it 60% is degraded, so only 40% will be there. So 864. Whereas 60% has become into methane, carbon dioxide, and other gases. So my total solids will be around 924 plus this one, so it is 71791. So this is my total solids as kg per day is there in my system. So now you have the kg per day value. Okay, you have to find out in terms of meter cube per day. So what is the loading rate or the accumulation rate in meter cube per day? So if we divide it something with kg per meter cube, okay, and the solid content in percentage, we will get the final answer. So this kg per meter cube is the density. Okay, so density they have directly taken it as 1000 kg per meter cube. So to be honest, this is not the actual scenario. In actual, the sludge density will be a little more. So it should be 1010 or 1005. It should be like that. But in the question, since it's not given, we are directly considering it as 1000. So that's why 1791 divided by 1000. And how much solids it's there? 5%. So it is 0.05. So this much is accumulating. Is it clear? Yeah, because here the density that we are taking is the total sludge density. Okay, so out of that 0.05 is my solids concentration. See, we have when we are finding volume, we have to do mass by density, right? The mass is of solid, but the density which we are using is of the sludge. So we have to find out the density of the sludge particles, that solid particles. So that's why we are multiplying it with 0.05 to convert into the solid density. Okay. Okay, fine. We'll move forward. I think you have noted it down, or if you want, I'll just zoom out. You can note it down for some time. I'll wait for. Are you able to see it clearly? Okay, I hope you are able to see it clearly. Okay, fine. Okay, we'll move forward. So the answer is 35.82 meter cube per day. Now, next question. Consider the following data from primary settling tank. Flow rate is 0.04 meter cube per second. Influent suspended solids is 260 milligram per liter. Removal efficiency with respect to suspended solids is 60%. Specific gravity of solids is 2.65. Specific gravity of sludge is 1039 kg per meter cube. So this is basically the density is given directly. Okay, the volume of sludge produced daily in meter cube per day is. So we have to find out the volume of sludge in meter cube per day. So again a similar question, but the way it is given is different. More or less it's a similar question, but it's related to only the primary settling tank. So here there is no degradation that is happening. So it is for the primary settling tank. Okay, so we'll solve this problem. Question number 8. Now Q is given as 0.04 meter cube per second. So I will just transform into meter cube per day. So it will come out as 3456 meter cube per day. Everything should be in terms of meter cube per day. Now influent suspended solids is 260 milligram per liter, or I can write it as 260 gram per meter cube. So everything in terms of meter cube per day or gram per meter cube in standards. Now suspended solids in kg per day. So how much suspended solids is being produced? So we will just multiply Q into the influent SS. So that is 3456 meter cube per day into 260 gram per meter cube. So I will get it as 898560 gram per day, or 898.56 kg per day. Okay, so this is the suspended solids that is coming into the system per day. Now the removal efficiency. So removal efficiency is given as 60 degree, 60%, not 60 degree, 60%. So what will be the mass of solids removed in primary sedimentation tank? It will be 0.6 into 898.56, that is 539.136 kg per day. Okay, so this much of mass will be removed per day. Now here we have to talk about sludge. So in the question, it is given that in our sludge, 6% is solids. Okay, PS, 6% is solids. So rest 94% will be water. Okay, so rest 94% will be water. So we can write it as mass of sludge is equal to mass of solids plus mass of water, because the total mass will be conserved. So we can write 100 kg sludge will be equal to 6 kg solids plus 94 kg water. So this we can write. So now this is the total mass of sludge solids that are being removed. Okay. So what will be my sludge produced? So sludge produced with 539.136 kg of solids will be equal to 100 by 6 into 539, because this 539 will represent only the 6% of solids. So my total sludge that is being produced will be 100 by 6 into 539. So 8958.6 kg sludge per day. Okay, so then we got the mass. So volume of sludge produced per day will be equal to the mass. Okay, the mass in kg per day divided by the density directly. So in the last example we used 1000, but here it is given as 1039. So 1039 kg per meter cube. So here we don't have to multiply with the solids content because it is already in terms of sludge. We have already found out in terms of sludge. So this will be 8.64 meter cube per day. Is it okay? Okay. So quickly I will just go through. So first we have to find out how much of suspended solids is there in kg per day. So we have to just multiply the flow rate into the suspended solids concentration. Then we know the removal efficiency. So we can find out how much of solids is being removed. Now we know 6% is solids and 94% is water. So we can write the total sludge will be 100 by 6 into 539.136. So after that, we will just divide with the density to get the volume of the sludge produced per day. So that is 8.64 meter cube per day. Simple, we can find it. That's it. Okay, just a minute. Just wait for 1 minute. Okay. So answer is 8.64 meter cube per day. Next question. So again, a match the type of question. So we have various techniques and their respective properties: conditioning, stabilization, dewatering, and thickening. So please try to answer the question, which is the correct option for this. Okay, so we'll discuss about it. So basically, if you see the conditioning, so why do you want to condition? Okay, C. So first is C, definitely because conditioning it improves the dewaterability. Then stabilization. So stabilization we do to decrease the putrescibility. Then dewatering will decrease the, it will increase the solid concentration. And then thickening will be done to reduce the volume. Okay, so I think option C is correct. So that is fine. Okay. So next question. Select the correct statements regarding methanogens. They are very slow growing. They are sensitive to oxygen and toxics. They can easily grow if pH is lower than 6. They can survive at very high temperatures. So which are the options is correct? Okay, so A and B are the correct statements because uh, because definitely these methanogens are very sensitive. So they are sensitive to this oxygen and toxin, and also they are very slow growing, and they cannot survive at high temperatures or even very low temperatures. And then the pH also has to be of a optimum range. So lower than pH 6 and all, it will be difficult for them to grow. Okay, so let it. So option A and B are correct. Next question. So again, small numerical, it's a one-liner numerical. Consider an aeration tank of ASP. The solid content is 4%. What is the pH range? So basically in the neutral range only they will easily grow. So in the question it is given at where they will easily grow. At acidic pH range, their growth will not be very much higher, whereas in neutral in 6 to 8 range it will be better, because after 8 again the their growth will be affected. Okay, so in near neutral range it will be fine. Okay, so density is also given in this question, and the sludge from the aeration tank is put into the sludge thickener to reduce its volume. So we have to calculate the density of the sludge. Okay, so just go through the question once again and try to note down the parameter. Okay, so let's see how to solve this. So there is a direct formula, or rather it's not a direct formula, we can use it in any question. So we know that the total volume is equal to the water volume plus the solid volume. Okay, so this I can also write it as total weight by total density, then water weight by water density plus solid weight by solid density. Okay, so total weight, I know if we take the total as 100, so 100. Now total density is not known, x. Water weight, we know 96% is there, so 96. Water density is 1000 plus solid weight is no, rest is 4. And solid density is the solid specific gravity. So that is 2.6 into the water density, 1000. Okay, so just you have to calculate x. So x will come out as 1025.23 kg per meter cube. Okay. Simple direct application of the volume and density terms. So we can solve this problem. Fine. Okay, so we'll move forward. So now some MCQs are there, so we'll quickly go through them. Select the options which can be used as bulking agent in composting. So we have to find out which of them can be used as a bulking agent. Food waste, shredded paper, leaves, wood chips, none of them. Let me know which can be used. B, C, D. Yeah, so definitely B, C, D is right because food waste cannot be used. So B, C, D are the correct options. Next, which of the following is likely to be not a major component of primary sludge? So we are talking about primary sludge, which is not a component of primary sludge. Inorganic sediments, dissolved organics, suspended organic matter, biomass reduced. Okay, so you are saying that biomass produced at the biological treatment stage. Okay, yeah. So here, if you see, we are talking about the primary sludge. Okay, so here dissolved organics will not be a part of my primary sludge. Why? Because see biomass. I think biomass can also be the answer, but if already some part of biomass is already present, it will settle down with the sludge. Okay. Okay, some part of biomass if already present, it will settle down, but dissolved organics will definitely be a not of part of the primary sludge, because in our primary sedimentation system, there is no chance that my dissolved organics will come into the primary sludge. It will be taken forward with the effluent to the next stage. So I think D should also be the answer, both B and D, but in the answer it was given as only B. Okay, so maybe they have considered biomass because it was already present, so it would have also been settled or produced later. Okay, but dissolved organics shall never be the part of the primary sludge. Is this fine? Yeah, biological treatment is secondary stage. Even I think that option D should have been considered, but I don't know from the source it was not considered actually. So maybe they are thinking like the biomass, maybe if it is already there in some kind of uh, in my primary sedimentation tank, then it can also be coming out as with the primary sludge. Okay, here I am talking about only which is present in the system already. But the point is that dissolved organics will definitely not be a part of my primary sludge. Okay, the next part. Again, it's a match the type. So we have waste activated sludge, sand and heavy solids, and oil and fats. So we have to find out, we have to match with grit removal, secondary clarifier, or skimming tanks. Please let me know the answer. Option A. So yes, the waste activated sludge will be removed in the secondary clarifier. Sands and heavy solids will be removed in my grit chamber, and oil and fats will be removed in the skimming tank. So option A is correct. Okay. Now, the sludge component that does not directly reach the sludge processing unit is return activated sludge, waste activated sludge, primary sludge, none of the above. So, which part of the sludge component will not reach my sludge processing unit directly? Option A. So, it's a direct thing because this return activated sludge will be bypassed back to the aeration tank. So, that's why they will not be returned to the sludge processing unit directly. Next, the volume reduction of the sludge is typically achieved through reducing inorganic solid, reducing water content, reducing biomass, reducing organic matter. So the volume reduction will happen basically through what? Option B, yes. by reducing the water content, we will be able to achieve the volume reduction, because the main content of any sludge is the water. So by reducing the water content. Next question. Which of the following is not an objective of the sludge thickening process? So what we don't do in a sludge thickening, reducing the total volume, increasing the solid content, reducing the water content, increasing the organic to inorganic matter ratio. So what objective is not achieved in a sludge thickening process? Option D, yes, definitely, because volume will definitely be removed by removing the water. Since we are removing the water, so the solid content will definitely increase. Again, the water content is reducing, but the ratio of the organic to organic will not be increased in that case. So option D is the correct answer. We'll quickly go through because these are very simple questions. Sludge conditioning can be obtained through iron salt addition, lime salt addition, hydrolysis, any of the above. Option D, yes. All of the things are correct, so any of the above is the right answer. So iron salt addition, lime salt addition, hydrolysis, anything can be used for sludge condition. Select the most appropriate option for statements A and B. The ratio of volatile to total solids indicates the organic fraction in the sludge solids. The density of a specific sludge sample is typically highest in the raw form and reduces with sludge processing stages. So you have to tell whether both statements are true, both are false, or one is the correct explanation of the other, one is false, one is true. So which of the options is correct? So we have two statements. One is about the volatile to total solids ratio, and one is about the density of the sludge sample, whether it will decrease or increase with the sludge processing stages. Option C. So A is true definitely, because how much my volatile component is there in my sludge, so that kind of represents the organic fraction, because the volatile fraction will be easily removed with the help of muffle furnace, so it is kind of the organic fraction. And then talking about the density, so with each sludge processing stages, my density will increase. Okay, so it doesn't reduce, it will definitely increase. The solid contents will increase and the water content will decrease. So option C is correct. Fill in the blanks. So we have thickening, stabilization, dash, hygienization, and drying. So find out the missing part. Please let me know which one is missing. Yes, so basically the missing part is the dewatering, because thickening, then stabilization, it is followed by the dewatering. So dewatering is the correct option. Okay, we'll move forward. Centrifuge, filter press, belt press are different types of mechanical sludge dewatering system, mechanical conditioning system, mechanical sludge hygienization system, mechanical sludge digestion system. So what are these types of? Option A. So basically these are dewatering systems and these are mechanical sludge dewatering systems. So option A is definitely correct. Okay, so these are various kinds of mechanical sludge dewatering system. Pretty direct question. We don't have much to discuss about it. Now next question, which of the following offers an option to use sludge for energy production? Okay, so is it land disposal, anaerobic composting, anaerobic digestion, both A and C? Option D, both A and C. Uh, why do you think that anaerobic composting can be an answer? Aerobic composting can be an answer because since it is aerobic composting, the byproducts that will be formed will will we have methane in that? Okay, so the only answer here will be anaerobic digestion. Okay, so anaerobic digestion can be used for the energy production. Okay, can someone tell me if instead of land disposal, if I have a engineered landfill, so can it be an option for this energy production if I have an engineered landfill? Have you, do you know about engineered landfill? Okay, so engineering landfill also there is a chance that anaerobic digestion can happen. Okay, in basically in normal land disposals, even if anaerobic digestion, yes, so methane will be produced in engineering landfill also. So if you are able to capture that methane and use it for energy production, then it can be helpful. But normally in most of the places that doesn't happen. So in India, we have very less engineered landfill. Most are just dumping yards. Okay, but whereas in European countries, there are many engineered landfills. So from there also they are able to generate some kind of energy with the help of methane. But with normal land disposal things, it is not possible. Okay. So, but in this question, the correct option is only anaerobic digestion because in anaerobic composting we won't get methane. Okay. Next, sludge hygienization is primarily the process of reducing the weight and volume of sludge, dewatering the sludge, reducing the content of pathogenic bacteria to an acceptable level, all of the above. D, all of the above. So here we are talking about only sludge hygienization. Okay. So when we are, if it is also mixed with the dewatering, drying and all those things, then we could have included the option A and B. But since we are talking about only hygienization, so hygienization means it is just concerned with removing the pathogenic bacteria to an acceptable level. So option C is correct, not all of the above. Okay, whereas in conditioning and dewatering thing, we will reduce the weight or volume, but not in hygienization. Okay. So here it is given that municipal sewage sludge hygienization or disinfection is a procedure to reduce the content of pathogenic bacteria in the sludge. Okay. So yeah, so the correct option is only C. Next problem. An apparent disadvantage of using a sludge drying bed for dewatering is. So, what is a disadvantage of a sludge drying bed? for dewatering. Complicated process, more applicable for industrial sludge, high energy requirement, large land requirement. Yeah, so definitely large land requirement, because in sludge drying bed we are simply uh, throwing this sludge on large land areas for drying. Okay, so we need a large area of land. So this is the biggest advantage, whereas there is no energy requirement as such. So the major disadvantage is the large land requirement. Okay. Okay. So now some more few numericals. Very simple. Okay. Yes. So basically, stabilization also we will remove the pathogens. Okay. The sludge is stabilized. We will remove the pathogens only. Or the basically it is called as the petriceability is removed in the stabilization. Okay, so in this question we have a batch of 4,500 kg of raw wet sludge with 98.5% water content is processed. Yeah, see, basically two things are there in stabilization. Apart from removing the pathogens, we will also remove the petricibility, that is the odor or the putrescence we say. Okay, odor is also removed from the sludge. Whereas in hygienization, it's a kind of disinfection. So where we are only concerned about removing the pathogens. Okay, so both are kind of similar, but stabilization we will also be concerned with the odor removal. Okay, because this odor will basically come from the decay of these microorganisms itself. So inherently the microorganisms are also removed. Okay, am I able to make it clear? Okay, so I will go through the question again. A batch of 4,500 kg of raw sludge with 98.5% of water content is processed, and the thickened sludge is produced is 1100 kg. Estimate the approximate water content of the thickened sludge in percentage. So you have to find out the water content in thickened sludge. Okay, so if we see, this is question number 25. Okay, so the solids content in 4,500 kg wet sludge. Okay, that is given as 1.5%. So 1.5% of 4,500. So that is 67.5 kg. Okay, so this is the solid content. So after reduction in water content, so suppose in this sludge I am removing the water content. So after reduction of water content, what will be my solids content or total dry solids? Can someone tell me? The initial solid content is 67.5 kg. So after reduction in the water content, what will be my total dry solid content? Can someone tell me? Are you able to hear me? Okay, so please tell me what will be my solid content after reduction in the water content in kgs. What will it be? So basically, even after the reduction of water content, there will be no change in the solid content. So it will be 67.5 kg only. Okay. So now the percentage of solid content. So now the percentage of solid content in thickened sludge, but the percentage will change. Okay, the total solid content in kgs will not change, but the percentage will change. So that weight is given as 1100. So we don't know. So let it be x. So 100 by x into 67.5. Okay. Or I can also write that x by 100 of 1100 will be equal to 67.5. I can write it in any way. Okay. So this is x is my percentage solid. So ultimately my x will come out to be 6.136%. So now we have to find out the water content of the thickened sludge. So water content of thickened sludge. So it will be 100 minus 6.136 or 93.86 or rather 94%. Is it clear for everyone? Is there any query? I will just go through. So first we will find out the solid content in my wet sludge. So there is no reduction in water content. So what is my solid content? It is given as 1.5%. So I know the mass of my solids. Now even after reducing the water content, my solid mass will not change. So it will be the same. Okay. So now the new solid weight is around 1100. 1 minute. What? Okay. So in my sludge, the new weight is around 1100. Okay. So X percentage of something is 1100. X percentage of my total solid content is 1100. It is coming. So now we can find out the X. So that will be my solid content in my new thickened sludge. So the water content will be 94%. Is it clear? Okay. So, okay. So now next question. Thickened sludge received from secondary treatment with a total volume of 60 meter cube per day and a total mass of 2550 kg per day is digested in a standard aerobic digester. The sludge percentage is 75 organic and 25 inorganic. 70% of the organic fraction is converted to liquid and gaseous products after digestion. Estimate the approximate mass remaining after digestion. So very simple question. You have to find out how much is still remaining after digestion. Okay. So just take a screenshot of this. I will quickly solve it. So inorganic and organic contents are given. We know that the inorganic content will leave as it is, whereas the organic content will undergo digestion, and after digestion some part will be remaining. So the total organic plus the part that is remaining after the organic degradation will be my total mass. Okay. So I will just solve it. So question number 26. So my first I will calculate the total inorganic fraction. So that is given as 25%. So 0.25 into 2750. So 2750 kg per day is coming every day. So that is 687.5 kg per day. Okay. Now total organic fraction will be 0.75 into 2750 something. Okay, but this total will not be coming out of digestion. So total organic fraction after digestion will be equal to, because from this 30% is remaining and rest 70% is degrading. So zero point 0.3 into 0.75 into 2750. So that is 618.75 kg per day. So my total solids after digestion will be, first this part 687.5 plus this part 618.75. So that will be 1306.25 kg per day. Okay, so like this we can find the answer. I hope it is clear. So 1037 kg per day. Simply we can write. So always remember, in any digestion unit, the inorganics will not change at all, whereas some part of the organics will be changed into the gaseous liquids and other things, and the leftover part will come out as from the digestion. Okay, the last question. In question number 26, if the density of the digested sludge is 1010 kg per meter cube and the solid content is 5%, the digested sludge accumulation rate is. So we have to find out the kind of um, density of my sludge, okay, in kg per meter cube. So we have solved the previous problem. Just in one step we can find it. So the density is given, the solids content is given, and we know that from the previous class that this much 1037 kg per day is coming out. So what will be my digested sludge accumulation rate? Can someone tell me the answer quickly? Very simple and direct. So if you want to see 1037 kg per day, that was my final answer. 1037 kg per day. You have to find out the digested sludge accumulation rate. Okay, so we'll see the answer. So basically what we have to do, we have to take the kg per day mass and divide by the percentage into the density. So this we have done previously also in previous questions. Similarly, we can solve this. So 1036.25 divided by 0.05 into the density. Everything in the denominator. So we will get it as 26 kg per meter cube. Okay, so it's just a single step answer. Fine. I hope it is clear. So, okay, so we are done with this lecture. I had this many questions, only 27 questions. I think we have solved enough for today. So if you have missed any of the questions, I will definitely upload this lecture in YouTube. So you can follow my channel and get all the contents there. If you have missed the previous questions. So we have solved many uh, subjective type numericals also before you people joined. Okay, and we will have the last session, which is an extra class for this course on 18th April. I think it's not Wednesday, it's Thursday. Yeah, it's Thursday. The date is fine, but I have incorrectly written it as Wednesday. So it's on Thursday, 6 to 8 p.m. Okay. Okay, so if you have any more questions regarding today's lecture, you can ask me right now, or you can mail me at shaha19akash@gmail.com. And if you have nothing to discuss anymore, you can leave the session. We will see you next week. So next week will be our last class for this course. And also, yeah, one more thing, if you have any particular suggestions or any particular type of questions that you want me to discuss in the last session, please mail me. Okay, please mail me or tell me now itself so that I can prepare accordingly. It will be better if you let me know by this weekend so that I can prepare it accordingly and we can have our session on Thursday. Any particular kind of question or any question that we have discussed earlier but you're not able to understand it, so I will discuss it again. Okay, so that's what is there from my side today. Anything else, you can please tell me right now. Or if you have nothing to discuss, you can leave the session. Thank you. Advection. Okay, I will note it down. So you need. So do you need problems related to advection, or you just want some MCQ type questions? I think problems will be better. Okay, so I will make a note of it. Advection, I will definitely include. Anything else, you just mail me. By this weekend, please let me know so that I have some time to prepare. Okay. Okay, thank you. You can close the session. You can leave.